So I'm very pleased to participate in this amazing gathering of all these brilliant people. And as I've already said before, and I say again, we thank Andrew for his indefatigable work as an organizer. And of course, we now need to append to that. Thank you to John Buchanan for being the initiator. It's a bit like being God, you know. The word became, and so on. So thank you, and thanks for everyone to listen to a bit more about the plasma. And I'm deeply moved and flattered that some of you have actually read my book. And there is an extra copy here that has been kindly given to me by Tim Eastman, who had two, to give to anybody who doesn't have one who wants one. And I have already brought my copy of Tim's book, which I'm going to get him to sign, and I've got two of Andrew's books for him to sign, and I've got one of your books to sign. The others that I ordered of some of the participants haven't come in time, so apologies. So I never was aware of any of you before, Nick Cook, of course, because he's well known. And I had met Bernard Carr before at Cambridge. We had a very good chat about astrophysics. He doesn't remember me. So, anyway, but he's unforgettable, so.
No, I do remember you.
Oh, well, that's very kind, Bernard. I met him with my great friend Chandra Vikramasinghe, and we'd gone to Cambridge together, and there he was waiting for us, Bernard. So I'll say a bit more about Chandra in a moment. So I believe
sorry to interrupt. Chandra was supposed to be here, but I had to
yes.
reschedule in the last minute, unfortunately. So
yes, that's
sorry.
right.
Go ahead.
Well, so I believe we all need to work very hard to move, to push forward more energetically than is currently being done, the creation of a genuinely new science. So my paper is called "The Need for a New Science," and I really mean that, and I'm sure everybody at this table thinks the same. I want to quote one of the most brilliant people of our time, the late Ilya Prigogine, and I had a wonderful day with him and his team long ago in Brussels. He won the Nobel Prize for Chemistry in 1977, and this may have been the most important sentence he ever uttered. Quote, "We are only at the beginning of science." And I think that has never been a truer statement. Yes, and we need to get more of a move on if we are to cope with the rush of events which may engulf us at any time now, with developments which will shake the whole world and everyone in it. And I think we all suspect what that might be. Some of you may have read at least part of my book. I now know that some of you read a whole of it, poor things. I shall not just repeat here what I've already said there, but I want to urge your attention to all of the things which I pointed out about cosmic plasma. Not that you need to be urged, because you've already urged yourselves. And also biological plasma, because plasma is all through our bodies as well. And as Albert St. Georgi discovered when he was the first person to suggest the existence of organic semiconductors in the body of all things. Not least is what I have said in that book and in my paper, which I did jointly with Chandra. And he sends his regrets, by the way, for not being here. He had to go back to Sri Lanka to see family members, to arrange the gift of a radio telescope to Sri Lanka, which he's pulled off, and also to see to a joint project that he and I have to sample biota in the high stratosphere. So he's very sorry not to be here, but he's here in spirit, as it were. And as you will all know who are familiar with my book, at the back of it is reprinted the paper that he and I did for the journal called Advances in Astrophysics, calling attention to the plasma aspects of the Kordylewski clouds. But we'll come to that. So they are situated at the Lagrange points L4 and L5 between the Earth and the Moon. most of you realize that. And those points are where the gravitational pull of the moon and the Earth balance out. So it had often been suggested in the past that it might be a place for an alien space probe to come to rest. We don't think that there's a physical probe there. I think that was investigated and found not to be the case long ago. But my old friend Jerry O'Neill, who was promoting space colonies, wanted the first human space colony to be at L5. And that probably wouldn't be a good idea. He didn't know about the clouds, unfortunately. He died prematurely of leukemia. It's a great loss. So, if you, anybody who didn't know about the Gorlevsky clouds upon arrival will certainly know about them upon leaving. And I'm sure we'll have a lot in the discussion about them, but I'm not going to talk about them now. And so, I want to stress with the greatest urgency that we push as hard as we can to persuade governments, agencies, trusts, funds, corporations, and frankly, anybody with any money to spare to increase the funds available for moving certain key areas of scientific research forward in an enhanced manner. I refer to such areas as the many different branches of plasma physics, and there's plenty of money in the part that's devoted to controlled fusion, so we don't need more money for that. In fact, I don't know if they'll ever succeed in that project, frankly. And then, of course, there's the plasma research that goes on in corporations for depositing microchips and nanochips, and that's all very secret, with corporations being very jealous of their techniques, and we don't need to be concerned with that either. And that's got plenty of money, but all the rest of the aspects of plasma research are underfunded. So we need to be kicking people in the ass to try to get more money out and expand with more plasma scientists. We really need them. Plasma scientists who don't get scooped up entirely by the corporations for chip deposition or by the military, because then you have to sign all the secrecy agreements and you can't have a discussion like this. And we need open science because the plasma physics is key to our future, and we can't allow it to be all wrapped up in secrecy. We can't afford to have that happen. And so the other branches that need to be encouraged are what's called hinge physics and edge physics. You might not have heard of those weird new disciplines. And all aspects of topological physics. Just to give you a quickie, when we talk about topological physics, one of the things they're concerned about is they discovered that with non-conductors, currents can actually flow along the edges and hinges of them, which is pretty weird and completely unexpected. And this all is just getting going, and we really need to figure that one out. They're not supposed to be able to have charged currents flowing along non-conductors, but they do in these weird edge and hinge situations, and it's all very geometrical and topological. That's why they call it topological physics. So that needs a lot more of a push forward, and in the complexity theory that they study at the Santa Fe Institute, although I don't think all of their papers are so fascinating, they were better when they were a bit earlier on at the Santa Fe Institute. But nevertheless, that's terribly important. And self-organization research, and especially when it leads to criticality, to all aspects of understanding of coherence and non-locality and long-range order, including many of the avenues to its understanding opened by the late Manfred Schroeder, and not all of which have been followed up yet. There are many loose ends there that need to be pursued. Manfred Schroeder has not had as much attention as he deserves. He's no longer with us, unfortunately. And we need to resume more intensive work on the general principles of how power laws and critical points dominate in large systems in order to have the open systems. But of course they have strange characteristics. There's the famous law about earthquakes, which means that you can't possibly predict where the earthquake is going to come, because the entire crust of the earth is one giant system. It's been proved beyond question that there is a power law controlling how many large ones, how many medium ones, and how many small ones. What you can't predict is where they will come. This is a really interesting field, and it was pioneered by a very great genius. I'm sorry, he's not Swedish, Peter, he's Danish, called Per Bak, B-A-K, which is kind of the Danish equivalent of B-A-C-H, I suppose. And he died early, which was a really serious loss, because he was leading the charge in this area, and somebody needs to pick up that baton, because a lot of his followers are doing it, but not quite with his flair and his genius. And there's a lot of geniuses come from Scandinavia. There's one here today. In fact, Schurz did.
Well done, yes.
You see? Now, tell us, Peter, how you really pronounce properly. Hannes Alfvén, is it?
Alfvén, I would imagine.
Alfvén. Yeah. Who Tim knew. Tim knew Hannes Alfvén. And by the way, somebody mentioned Don Scott. Wonderful, wonderful man that we got to know, and we're still in touch with Agnes. And of course, Don is still there, but I think he might have subsided a bit, if you know what I mean. And poor old Wal Thornhill has died young. But the electric universe theory requires very close attention, because I absolutely subscribe to it. The business of electric currents going between the stars, which are the filaments that we see in the cosmic web photos, and then the nodes are the stars. But I'm not talking about that. So then I myself have managed to unravel the hideously complex ideas of Gabriel Krohn, K-R-O-N. You might not have heard of him, but keep your ears out, because you will. He died years ago. I organized this because he did not live long enough to prepare it himself. He's another one who died early. And so I've had to piece together his broad ideas from bits and pieces of his hideously technical writings, scattered all over the place, because he didn't bring them together into an exposition, because he was really writing about electrical networks. He worked for General Electric, and he was the person who figured out early on how do you join all the separate networks which used to be in the United States into one giant national network. You might think that's easy. That was one of the most difficult problems of the 20th century, and it was Gabriel Krohn who solved it. He was a very great genius, totally unrecognized. He was a Romanian exile. He fled to America. He worked as a ditch digger for years in somewhere like Oregon. I don't know where Oregon is, do you? Anyway, something like that. Then he was discovered, given a job at General Electric, and they realized they had a genius on their hands. And so I'm about to be publishing that, because I think he was on the par with Tesla as a genius, and little you've known, this will appear in a book I will publish if I can ever restrain myself from constantly enlarging it. Its title is The Many Faces of Unity in Science, Nature, and Mathematics. And it commences by extending the ideas of Bertrand Russell about arithmetic, and then extending that across many disciplines, but I will talk more about that. So I realize that many and most people here today are great enthusiasts for Whitehead. When I was young, I was a passionate enthusiast for Whitehead, but I regret that I haven't had time to reread all my Whitehead books before the conference, because he came up quite suddenly. And so I hope to catch up with you one day, because you're all experts, and I'm just somebody whose heart palpitates in the corner for Whitehead. So, 3 cheers for you. And I have to try and catch up. But let us all put our hands on our hearts and swear that we agree with Whitehead in his absolute and passionate insistence that science must be open to the investigation of any and all phenomena, no matter how strange. Key. And we certainly need to follow that advice now more than ever before in human history. And he offers such inspiration that anything we can do to promote him should be done. Of course, you're all doing it, so I hardly need to say that. At the moment, I'm writing a paper on the history of what I believe to be the attempts of the Kordylewski cloud at L5, which I believe to be intelligent, as probably most of you know, to communicate with us little humans crawling around on this planet, with a process which has been going on for a century, but which has been recognized by only a few investigators, several of whom I knew and that died, I realized that all of the facts which can be collected about the history of this must be gathered together as a first step to our thinking about what it all means and what our next move should be. I will give precedence to the persons attending this conference in circulating this history when I finish it. I'm getting there. And I think the full story needs to be told before we start trying to consider it, what it means. In other words, my favorite philosopher being Aristotle, he always got all these ducks in a row and then he started talking. And that's what I like to do, especially when it's historical. We wouldn't know anything about the pre-Socratics if it weren't for him mentioning them in the metaphysics. Now, I want to point out what is wrong with our present science. That's a rather bold thing to say, but I think we all agree there's something really seriously wrong with it. Now, please don't be too upset, Bernard, because you're a very conventional man, really. But many of the points I shall make did not originate with me. They include words of wisdom from some of the most famous scientists of our times. I shall start with a big shock which I had when I was a young man. My wife Olivia and I were close friends of Peter and Helen Mitchell. So close that we went on holiday with them in their house in the south of France and often stayed with them in their mansion, Glyn House in Cornwall. So, Peter had won the Nobel Prize for Chemistry in 1978 for explaining how energy was dealt with in cells. He showed, for instance, that proton currents were flowing across cell membranes, and as were calcium ions, and so forth. Imagine, therefore, my surprise when this world expert on bodily energy said to me in one of our many conversations, "We don't really know what energy is." Well, my wife and I were also good friends of the physicist David Bohm and his wife Sorrel. She was really Sorrel, not Sarah. Most people think she was Sarah, but Sorrel is an Israeli name. And they were Jewish, as you probably know. In my many talks with David, a lot of which I taped, I must have them transcribed one day, he shocked me even more than Peter Mitchell had done. And I know these words of his are exact because I taped them. Quote, "What is an electric field? What is an electric field? We don't know. If we knew, we would know why field and charge are connected in the particular way in which they are. When I was a child, people would say electricity is very mysterious. Now we say it's not so mysterious, but still nobody knows what electric force really is. We're used to it, that's all, by giving it a name and getting used to handling it. What is a gravitational potential? You see, you would have to explain all the forces and explain why they act on particles. Now nobody has done that. This is David Bohm talking, and he said a lot more like that. And most, or all of us, are familiar with Richard Feynman's famous comment, "I think I can safely say that nobody understands quantum mechanics." Well, that's a big statement too, and that's well known. The famous Nobel laureate Percy Bridgman, another of my heroes, said he did not know what a field was. Didn't know what a field was. And he added that nobody else did either. He made similar statements about mass, charge, force, and so on. Nobody knows what any of them are, he said. He's published several books to that extent. He did this after he retired at Harvard and couldn't be a victim of vengeance from the establishment. Very courageous man, brilliant, Percy Bridgman. So, and it is true, no one knows what any of the most basic things discussed in our science actually are. We speak of them as we might speak of people who live as recluses in the house next door. We say, the neighbors are at home. They put their lights on. They mowed their grass. They're not playing music this evening. We can smell their cooking. And their dog keeps barking. But we have never really seen them. We might even call them Joe and Sally because we know those are their names, but we have never even met them. They are familiar as concepts, but unknown as real people. So can someone tell me, please, what mass is? what force is, what charge is, what energy is. We operate like blind people feeling things on a factory production line, things which we have never seen, and we don't even know what they are. And we call that science? To be ignorant of what the most basic things are means that we are still only playing at science. We have to try harder to understand rather than just to manipulate and calculate. Another thing which has been wrong with our science for centuries now is that it is infected with the deadly virus known as reductionism. I'm sure we all agree on that one. We need to detox the science which we do have, because even what we have achieved often has rot at the center. Like sometimes when you pick a plum from a tree, bite into it, and find a wriggling creature inside. There is absolutely no future in trying to construct a science from the bottom up by collecting bits and pieces and putting them together into what you hope will be a sensible grand structure. It just doesn't work. We have to think of wholes and then descend to parts. Wholes simply cannot be constructed from welding parts together like someone who owns a junkyard. Good old Bucky Fuller, whom I knew, brought a nearly obsolete word back into use: synergy. It was Bucky who did that. Synergy. Hence, synergetics, etc. The word has caught on, and now everybody uses it. We can be guided by Prigogine and all the other brilliant scientists who have tried to tell us about the importance of a holistic science. Even Ludwig von Bertalanffy, way back in the 1920s, was trying to tell us with his general systems theory, which he kept elaborating for decades, as I'm sure most of you know. As Per Bach said in his brilliant book, How Nature Works, quote, "The philosophy of physics, since its inception, has been reductionist. That the world around us can be understood in terms of the properties of simple building blocks," unquote. But this is simply a recipe for how to get nowhere. And some of the most powerful and exciting discoveries about the unique qualities of wholeness are those of Gabriel Cron, when I get around to publishing them. His findings are absolutely astonishing and undeniable, and most surprising. You'll be amazed when you finally see what he discovered by working with electrical networks. It's totally mind-blowing, and nobody knows about it yet. For there are qualities of wholes which emerge, which are certainly not a result of adding parts together. And we have to get beyond the reductionism. We have to push this with all of our might. Science also needs to have more of a historical perspective, with people looking back through old books and old journals for ideas which were passed over at the time, but which may have great value for us now, or at least need examining. Not long ago, I got hold of an obscure article, many decades old, by one of my favorite scientists, Charles Proteus Steinmetz. In it, he described how he thought that the only way to lay out a chart of the elements sensibly was by making use of a Möbius strip. To do so, the boldness of that concept took my breath away. It took the power of an imagination to another level entirely. Some people despise that which is old, just because it is what people dismissively call today not relevant. You know, the 5-second attention span. Oh, that's yesterday. No, we mustn't do that. Sometimes the oldies are the goodies. We must all be like Whitehead, open to anything. And those of us here today already are. I mean, we have a conventional cosmologist sitting next to Andrew at the moment, who has been the president of the College of Psychic Studies. Well, that's what I call being open.
Yeah.
And congratulations to you for being so open. You're one of the most open British astrophysicists. Absolutely. I mean, who else is there? I mean, let's look around. Is there anyone else? Now to finish, and perhaps cheer you up a bit, I have an unusual thought to propose to you. Although the universe is well known to be composed of 99.9% plasma and only 0.1% atomic matter at the most, and therefore our science is pretty useless for understanding a plasma universe, although it works so well for us here, it may have one unsuspected advantage. imagine that you are the giant Kordylewski cloud, and you know all about the science of the plasma universe, because you're a plasma entity after all, and you're in touch with all the other guys and gals, because apparently, well, you never know. I don't know whether trans goes on in the plasma world. But what is there that you don't know and would dearly like to find out about? Try thinking for a moment. What is there that the Kordylewski cloud doesn't know and needs to know and wants to find out about? Why the science of a primitive civilization like ours, which is made out of something rare and strange, something that it is not well known to you at all, atomic matter, where the charge is balanced in things called atoms. I mean, it's so unusual. And so, the Kordylewski cloud's only way of really understanding atomic matter is to monitor a civilization of creatures made of atomic matter. How else can they find out? And let them develop a science which suits them. And in that way, they can be the cloud's researchers. We might be the researchers for the Kordylewski cloud. And tell it all about a physical world. So we may be under surveillance not just as an experiment and as a curiosity by cosmic anthropologists, but as a unique source of information about our closed little bubble in which we live. In other words, our primitive science may be just what the cloud wants to know and has no other way of learning. Let us not be downhearted. No, not downhearted. We may genuinely have a lot to offer. Giant inorganic intelligences, after all, have no way of drinking a pint of beer or having a cup of tea. Nor can they straighten their ties, put on lipstick, or go to sleep at night. But we can.